morning, dear students. Hope you all are doing good. Let us begin with the next session of the third chapter, that is current electricity. So, today we are going to study about Ohm's law. Ohm's law is an important law in this chapter. You're going to Ohm's law in your board exams. Okay, Ohm's law is like Coulomb's law, which was very important in the first chapter. Here in the third chapter, Ohm's law is very important. You are going to get it in your exam, the guaranteed question, Ohm's law. You may get it as define Ohm's law or explain Ohm's law with the expression. Okay, or explain the limitations of Ohm's law. Okay, so there is no derivation in Ohm's law like Coulomb's law. There is no derivation. There is only the statement and the expressions and the explanation of the expression. That's it. Okay. And there are the limitations of Ohm's law. So this is going to be a very important law. So now let us start with Ohm's law. So Ohm's law states that, okay, please write down. Ohm's law states that potential applied across the ends of the conductors, okay, potential is V, okay, potential applied across the ends of the conductor is directly proportional to the current flowing through the conductor, that is, V is directly proportional to I. V is nothing but the potential difference or the potential across the conductor, across the ends of the conductor, right? And I is the current flowing through the conductor, and V is directly proportional to I. That is, the Ohm's law states that, I'll repeat it again, potential applied across the ends of the conductor is directly proportional to the current flowing through a conductor. Okay. So now this can be written as, this V is directly proportional to I. This can be written as V is equal to Ri. V is equal to Ri. Okay. Or I can say the final expression, which is very important to understand or to remember, or very easy to remember, is V is equal to IR. So this is the expression for Ohm's law. Okay. So now what is R? What is R? R is called as the constant of proportionality. Okay, constant of proportionality, which is called as resistance of the circuit. R is called as the constant of proportionality, that is the resistance of the circuit. Okay, the electric resistance, this resistance of a conductor is defined as this resistance, that is this R is defined as the ratio of potential difference across the ends of the conductor to the current through it. Okay, to the current flowing through it. And the SI unit is, the SI unit of resistance is nothing but ohm. Okay, ohms. The SI unit of resistance is ohms, which is denoted by the symbol like this. This is called ohms. Okay, resistance is always denoted with this notation, that is ohms. For example, resistance R is equal to 10 ohms or 20 ohms, like this. Okay, so this is the SI unit of resistance. Resistance is said to be 1 ohm. So how do you define one resistance? Resistance is said to be 1 ohm if 1 volt of potential difference is applied, or that is 1 volt of potential difference applied produces current of 1 ampere in it. Okay, so this is the definition of resistance, means 1 ohm of resistance. Okay, 1 ohm of resistance. So this is all about the Ohm's law. It is very simple. You will get it for 2 marks with the explanation of the expression. So just if they ask you for 2 marks or 3 marks, write the statement, that is Ohm's law states that potential applied across the ends of the conductor is directly proportional to the current flowing through the conductor. And then write V is proportional to I. That is the explanation, that is the statement. Then you introduce the constant of proportionality R, that is resistance. Therefore, V is equal to Ri. And then you can write V is equal to IR. So this is the answer for the Ohm's law if they ask you for 2 marks or 3 marks. Okay. So you can remember this VIR as very important relation. Very important relation. Okay. What relation? The relation between the potential and the current. Okay, very important relation, that is V is equal to IR is nothing but the Ohm's law. This is very important throughout the chapter. Okay, throughout the chapter, V is equal to IR. Okay, and this R is equal to IV, or V, sorry, VI. R is equal to VI. These two expressions are very important in throughout, throughout the chapter. This is very important. Okay, so now let us understand the limitations of Ohm's law. This is also very important question which you may get in your board exams, that is limitations of Ohm's law. If they ask you together, in case if they ask you together, that is define Ohm's law and explain the limitations of Ohm's law, you may get it for 5 marks. There is no derivation, but if they ask the questions together like define Ohm's law and explain the limitations of Ohm's law, you may get it for 5 marks. So what is the first limitation of Ohm's law? The first one is, let me clear this, let me clear the screen. Okay, the first limitation for Ohm's law is Ohm's law is only applicable for metals. Okay, Ohm's law is only applicable for metals. Okay, and this is not applicable for electrolytic solutions. That is, electrolytic solutions do not obey Ohm's law. Electrolytic solutions do not obey Ohm's law. Ohm's law is applicable only for the metals. So what are electrolytic solutions? We have learned about this in the previous class. Electrolytic solution is a solution in which we can pass the current. For example, the solution of common salt and water. So Ohm's law is not applicable for electrolytic solution, or you can say electrolytic solutions do not obey Ohm's law. So this is the first limitation. And the second limitation is Ohm's law is not applicable for semiconductors. Okay, Ohm's law is not applicable for semiconductors. That means semiconductors do not obey Ohm's law. And in the third limitation, in the first I said Ohm's law is applicable for metals, but here also there is a limitation. Ohm's law is not applicable for metal with very low temperature and with very high temperature. Okay, it is not, I told you this is applicable for metals, but even in that there is a limitation. It is not applicable for metals with very high temperature and with very low temperature. It should be in a moderate condition. Okay, the metal should not be with a very high temperature or even with a very low temperature. It should be moderate. So this is the third law, third limitation. And the fourth one, Ohm's law is not applicable for metals when the current is extremely high in the metals. So the fourth one is Ohm's law is not applicable for the metals whenever the current flowing through these metals is extremely high. When if the current flowing through this metal is extremely high, then the Ohm's law is not applicable. Why? Because whenever there is an extremely high current, large amount of heat is produced. So it comes to the third limitations. Whenever there is a high temperature, the Ohm's law is not applicable. Okay, very simple. See, it is applicable only for metals, whereas in metals there are two limitations. The metal should not be at high temperature, very high temperature, or at very low temperature. It should be in the middle or to the moderate temperature. The fourth one is, if the metal is having extremely high amount of current, then the Ohm's law is not applicable for such metals. Why? Whenever there is extremely high current, there will be a large amount of heat produced. Simple. So the fourth limitation says that the Ohm's law is not applicable for the metals whenever there is a flow of current at extremely high rate. Okay, so this is the fourth law. So if I explain you with the graphical representation the limitations of Ohm's law, this is very important graphically. So let me consider the graph of current versus voltage. Okay, the current versus voltage. If I plot a graph of current versus voltage, so x-axis I'll take voltage, and y-axis I take I, that is current. So if I plot a graph of voltage versus current, the graph will be a straight line. But experimentally it is not a straight line. Experimentally this is not a straight line. Okay, As the voltage increases, current also increases, which produces more heating effect. Therefore, the graph becomes, I'll draw it here, the graph, this graph experimentally, it becomes curved, little curved, okay, like this. See, theoretically they say it's a straight line like this, but experimentally it's a curved graph like this, okay. This means whenever there is a curve in the graph, in case of Ohm's law, whenever you find a curve, this means that the Ohm's law is not applicable. The Ohm's law is not obeyed. Here it is obeyed. If there is a straight line, then this is the Ohm's law is applicable. If you see a curve in the graph is same, voltage versus current, the same one. This is theoretical, and if you do the same thing experimentally, there it's not a straight line. It is a slight curve. Okay, it bends slightly. Why? As the voltage increases, current also increases. Okay, this is experimental representation. Okay, here the Ohm's law is not obeyed. In case of semiconductors, if I consider semiconductors such as diodes and transistors, we will study about the diodes, the Zener diodes, the transistors, p-type transistor, n-type transistors, everything we will study. It's a very interesting chapter. Semiconductor is a very interesting chapter. We will study in details in the last chapter, but here for the understanding purpose, if I consider semiconductors such as diodes and transistors, diodes and transistors are the type of semiconductors. Okay, if I consider such semiconductors, and if I plot a graph of I versus V, the same thing, current versus voltage, the graph is a linear curve. Okay, it is a linear curve. That means the Ohm's law is not obeyed in semiconductor as well. We have written it, right? The same thing I am showing you in a graphical representation. So if I consider semiconductors and plot a graph of current versus voltage and current, okay, so the graph will be linear curve like this, linear curve. So here is a curve, that means Ohm's law is not obeyed. Okay, this is all about the limitations of Ohm's law. Very easy. Limitations and the Ohm's law and the expression of Ohm's law is very easy. You may easily get the full marks if they ask you. So study well. This chapter has the maximum marks. Okay, this chapter has the maximum marks, and I can say this is the very easy chapter. You know, if you concentrate, this is very easy. Current electricity is very easy. Okay, next class I'm going to deal with a very interesting concept, that is the color coding of the resistors. Okay, the color coding of the resistors, you will love it. Okay, it is a very interesting chapter, the color coding, how you do the color coding and how you will get the value of the resistors and all. We will see that in the next class, but now we will continue with this. Okay, so this is all about Ohm's law and the limitations of Ohm's law. Now let us go to the another concept, that is free electron mobility. Mobility of the free electrons. So what does it mean? Free electron mobility is the study of movement of electrons in the conductors. Okay, what is the movement of conductor, or what is the movement of electrons in the conductor? We get to understand whether the movement of electrons is taking place easily or they are facing some difficulty. Okay, if we study mobility, mobility is nothing but the study of the movement of conductors. We will understand whether uh, the electrons are moving easily or they are facing some difficulty. Okay, this is nothing but mobility. Mobility can be defined as, mobility is defined as the magnitude of the drift velocity per unit electric field. Write down, mobility is defined as the magnitude of the drift velocity per unit electric field. Understood? It is the magnitude of drift velocity per unit electric field, and the mobility is denoted by mu. Okay, mu, what it is called as mu. Mobility is denoted by mu, and mu is equal to magnitude of drift velocity per magnitude of electric field, right? Magnitude of drift velocity divided by magnitude of electric field. If this ratio is high or if mobility is high, then the electrons are moving easily. Okay, if the mobility, if the mu is high, if mobility mu is high, the electrons are not facing any difficulty, they are moving easily. If the mobility is low, if this ratio is low, if this mu mobility mu is low, then the electrons are moving with some difficulty. Okay, the electrons are moving with some difficulty. So I said the study of mobility will help you to understand whether the electrons are moving easily or they are facing some difficulty in the movement. Okay, so this is mobility. Mobility of free electrons is a scalar quantity, and the SI unit of mobility, okay, there are two units for the mobility, that is mu. There are two units. The first one is ampere meter per newton, ampere meter per newton. Okay, and the second one is meter square per voltage into second. Okay, so there are two units. If they ask you, you can write any of the unit. There is no particular unit. And if they specify you with the ampere and all, if they tell you to write in terms of ampere or in terms of potential V, sorry, voltage, then you can say sorry, potential, then you can write the respective units. Okay, if they don't mention you with a specific name, then you can write any of the units. So this is the SI unit of mu. Okay, understood? This is all about the free electron mobility. You may get it for 2 marks. Okay, the definition and the expression and the SI unit. So it's a very simple definition. Here I'm saying you can score very well in current electricity because there are simple definitions, simple expressions, and there are some derivations which we will study in the coming classes. Okay, there you might find difficulty, but if you understand, then they are going to be very easy. So in case of definitions and the statements and the expressions, this chapter is very easy. So you are going to get many definitions in this chapter. So this is about the free electron mobility. So now let us go to one more very important concept, one more very important concept in case of theory as well as in the practicals, Okay, so that is resistors. Resistors. The name itself says that it is something that resists, right? Resistors. It's something that resists, right? Something which is opposing the movement of something, that is resistors. Okay, so now let us study about the concept of resistors and also about the resistivity of various materials. Okay, resistivity of various materials. I have decided to take this classes in parts. Now I'm just going to explain it, okay, without the diagram and all. In the next class I'm going to show you in the slides. Okay, I'll show you the slides of the resistors, how to code the colors of the resistors. Okay, we will see that in the next class, but now we will understand what are resistors, just the basic history of the resistors. Okay, so now what do you mean by resistors? Resistor is a device. Okay, resistor is a device which opposes the flow of electrons in a conductor. Resistor is a device which opposes the flow of electrons in the conductor. If you want to oppose something, if you want to oppose the movement of electrons, you use the resistors in your practical. See, you can see the humps, okay, or the speed breakers on the roads. You can just compare that with a resistor. It is opposing the speed, right? It is opposing to control the speed. So similarly, resistors are opposing the movement of the electrons or the flow of the electrons in the conductor. Resistors are always denoted by the symbol R, and the pictorial representation of the resistor is always drawn like this. So this is the diagram of the resistor. Whenever you see this representation in a circuit, this is understood as a resistor. Okay, This is understood that it is a resistor. When you go for practicals, when your practicals will start, you will be having some circuit diagrams. Okay, according to the diagrams, you have to connect the instruments, and whenever you see this symbol in the circuit diagram, this means there is a resistor, and you will be having the values here, okay, like 10 ohms, 20 ohms. Okay, so this is about the resistor. And now there are two types of resistors. Okay, two types of resistor. One is wire bound resistor, and another is the carbon resistor. The wire bound resistors, these resistors are prepared based on the formula R is equal to rho by L divided by A. Okay, R is equal to rho by L divided by A, where R is the resistivity, L is the length, and A is the area of the wire. Okay, based on this formula, these wire bound resistors are constructed. So what is it? Rho into L by A. Rho is nothing but resistivity, L is the length, and A is the area of the wire. In laboratory, we use the resistance box as well as this wire bound resistors. Okay, they are nothing but the wire resistance box, and some one more resistor will be there, somewhat like a round thing, and you'll find the resistor on top, and the see it will be like this. I'll show you when the practical starts. I will show you all the two three types of resistors. Okay, here will be a resistor like this, and if you turn it, if you do it upside down and see, and you will find the wires here like this. Okay, and one more is the resistance box. The other day you all had come for the physics department, and you saw a big box with a different keys in it. Okay, it was a wooden box, and there were keys, black color keys in it. Okay, so it was something like this. There was a box. In next class I will show you the picture of that. So it was something like this, the box, and here were the keys on that, black color keys, two rows of keys. Okay, so this is called as the resistance box. The this resistance box is also a form of the wire bound resistor. Okay, the wire bound resistors, these wire bound resistors are very expensive and they are bulky. Okay, very expensive and they are bulky. And whereas this carbon resistors are made up of carbon, and they are much cheaper compared to that of the wire bound resistors. Okay, carbon resistors are made up of carbon. Okay, and they are very cheap compared to that of the wire bound resistors. So now these carbon resistors have the color bands on them. Okay, color bands. It will be like this. There is a small resistor here, and it has a wire, and you will find some colors on this color bands. Okay, this we will study in the next class with the slides. Okay, there will be color bonds. There will be no value printed on this. The value of resistance is not printed on this. There will be some color bands, and you have to be thorough with the coding of this color bands. If you are thorough, if you can code the colors, then only you are going to get the value of this resistor. Okay, the resistance value will not be written on the carbon resistor. Please remember, you should be thorough with the color coding. If you understand the color coding, the three colors, if you code all these colors, then only you will get the value of the resistance. Whereas in the wire bound resistor, the value will be written. Okay, like 10, 20, 30 ohms, 40 ohms will be written. So it is very easy to understand the value of the wire bound resistor because it will be written. Whereas in this, there will be color bands like this, and you have to understand the color bands to get the value of the resistors. Okay, so this you will use in the circuit board connection. Okay, if you want to see, then you open any electronic devices like a remote control. Okay, remote control of any TV, old remote control, the spoiled one. If you can open, then open and see in the circuit board. Okay, you will find a small resistor, small capacitors. Okay, those are nothing but the carbon resistors, and these are very bulky. We use them in laboratory. Even this we use in laboratory for the circuit board connection. Okay, this is all about the resistor, just the explanation of the resistor. The color coding and all in depth we will study in the next class with the help of the PowerPoint presentation. Okay, so this is all about the resistors. In the next class, we will study the resistors in deep. We will learn about the color coding. Okay, so now let us wind up the class and we will meet in the next class. Thank you.